So, we have understood the various possible methods of adding elements into a set by using add, update, and we have also seen how to remove elements from a set, right? Remove, discard, pop, clear. Now, let us understand some mathematical set operations, because whenever you see set, you remember it, you study in mathematics, right? So, here we have some mathematical set operations which includes union, intersection, difference, symmetric difference, and so many things. Let us make it simple by understanding union. If you see this example, we are combining two sets, and why do we, the difference between union and update is pretty much simple, because when I go for union, it returns a set that contains all items. See it? That means it depends within the simple definition, it depends where whatever the type of elements you are passing, whether it is numbers or whether it is a string, where automatically it combines the elements. When you go for update, only one thing will be updating here. Here I am trying to make sure that it is permanent in the case of update, and if you go for unit, it is temporary. Okay, let us prove it. So, let me open the same ideally which we have discussed, right. So, let me create a set, whether it is of numbers or whatever it is, and let me give b is equal to, you need not give same numbers, because we even go with symbols also. Symbols for this intersection, union, difference, symmetric difference, we have so many things. Let me start with this. Z is equal to a dot, when I store in a variable it is permanent, but first let us see a dot, when I go for update it is permanent, but when I go for union, you see a dot return the union of sets as a new set, a dot union of b, you see every element is combined. But that does not mean that A is modified. No, this happens with update. So, update will modify, union will combine, that is it. Just remember in that way. Update will basically modify the elements. So, it is for your clear understanding purpose, modify the elements, but union will basically combine. So, the best thing is you can take one more variable and store it in that, then you can clearly understand a dot union of b. So, Z is now the combination of your elements in both the sets. In a similar way, we can also use a symbol called as, what is the symbol we can use basically? We can basically use bar, right. You have bar symbol in your keyboard, right. Just the keyboard, above the key enter, you have bar. So, bar is basically for union you use. Let me prove that. A bar B, what happened over there? You see the same result, right. So, bar is for union, you dot union you use for keyword, bar is for symbol. Even you use Z is equal to A bar B, you get this thing. So, make it very simple, bar is for union. Now, what if you want to take some common elements from that? There you go, you have one more thing called as intersection, because in sets, if you remember, intersection will take the common elements from both the sets. A dot intersection of B, do we have any common elements? One common element, because it is 6. That means union is different, update is different. When I go for intersection, it will only check for common elements, right. A, B are same again. If you want to update B with some more common elements, then do that. B dot update of what shall we give 1 4 5, it's fine. Okay. Now, B has been modified, A is as it is. So, you are having 1 4 5 as common elements. Now, you go A dot intersection of B, you get all the common elements. In the similar way, you have one more symbol for it, which is ampersand. Yes, you are relating it to your operators, right, logical operator, where you have used this bar, AND gate, OR gate. Yes, we will be relating that thing also in operators section. So, ampersand is used for intersection. When I go for ampersand, it is intersection like this, A ampersand B, you got all the common elements. So, ampersand is for intersection, bar is for union. So, this is how you can clearly understand the difference between ampersand and bar. Now, what if you have one more function which is nothing but which can modify the common element, that is intersection update. What does that mean? It is performing both intersection and update at a time. Yes, That means it will update the common elements into the original set. Let me prove that. A dot intersection update. You just need not write anything, just go with the functions over there, just press enter, update a set with the intersection of itself and another. That means the common elements will be updated into the original set. Let us see. Okay, something has happened here. Let me press enter A. You see what happened? 1, 4, 5, 6. What are the only common elements? So 1, 4, 5, 6 are the common elements. So 2 has been taken out permanently. That is the key point. If you wanted to update the common elements into the main set, use intersection update. You don't have union update because union is different, update is different. Intersection is different, intersection update is different. Right? Union, intersection is very much easy to understand. Next comes the important concept of difference and difference update. So A dot difference. If you remember from your mathematics, what does difference will do? It will just check what are the elements present in both sets. It will print only the elements present in another set. That means what are the common elements in both A and B? 1, 4, 5, 6. So it will remove 1, 4, 5, 6 and print the elements only present in A. But you are getting empty set. Yes, because you don't have any elements in A other than common elements. So what should I do? Let me update it for you. A dot update of, what happens if I give like this? Yes, you got an individual characters over there. So try all possible ways, just go with the methods, it will be easier for you. Now I will try to give A dot difference of B will make sure that you get only the other elements which are not common. But that doesn't mean that it is modified permanently. No, the original things are as it is, right? Even you have a symbol which is minus. You press minus symbol, that means whenever you keep minus symbol between A and B, that performs difference operation. Set difference. Let me prove it like this, A minus B. That's it. You see, the result is same, A dot difference of B and A minus B. That doesn't mean that you can perform A plus B. No, you cannot have plus for union. Plus operation is not possible for sets. You cannot also repeat the set, because if you repeat the set, what happens? You get duplicate. So just make these tricks. It will be very much fun to use. Right? Now A is as it is, B is as it is. If I want to update the elements, there you go, again you have difference update, A dot difference update. Every function we are discussing over there removes all elements of another set from this set. A dot difference update of B, there you go. That means the common elements have been removed and you can see A has been updated. You see, again the order is changed and B is as it is. But in the previous case, you see, whenever you perform difference and again A is not changing. Always remember, whenever you perform intersection update and difference update, you see the updation has been done into the original set. Always remember that point. It is very much easier. So what does difference has done? Difference will take common elements. If I give B dot difference of A, what are the common elements in B and A? It will remove and you replace the other elements in B. That's it. So difference update. Now as we are not having any common elements, again I should update it, because I wanted to explain you the other concept, which is symmetric difference. Okay. Now A is this, B is this. I will go for A dot symmetric difference. Same mathematical property, it returns the symmetric difference. The main difference between difference and symmetric difference is, in difference what is the thing? It will take common elements and it will print only the elements of one set. But if you go for symmetric difference, it will take the common elements and prints the elements which are present in both the sets. That is very, very important point which you need to remember, right? You see, every element. So prints, it removes common elements, it removes the common elements and prints remaining elements. That is the key point when you go for symmetric difference, and prints remaining elements in both the sets. So, wherever required I am writing comments, you need not worry about that. So, symmetric difference will make sure that it will remove common elements and will print the remaining elements in both the sets. But doesn't mean that it's modified, no? No. Whenever you use symmetric difference update, then only it will be modified. So, you also having symbol like cap. You can see on your 6 number on the number pad which you have above the alphabets. So, cap is for symmetric difference. So, whenever you use cap, that means you are performing symmetric difference. Always remember these symbols because we will be using the same symbols in operators. That means if I give A cap B, you get all the elements in both the sets, right. Now, A is as it is, B is as it is. What do I do now? If I want to update, I just use A dot symmetric difference update of B. That is it. The A set will be updated. You see it here now. The output has been modified into A. But in the previous case, if you observe, A is as it is. You see here, A is as it is. You do not find now 1, 4, 5. See, because those are common, 1, 4, 5 are common because you are updating it. Intersection update, difference update, symmetric difference update will just try to update the elements. So, make it simple when you are working on update functions. It becomes pretty much easier, you need not remember anything. Now, whatever we are left, A dot, we have seen add, clear, copy, difference, update, intersection. We have each disjoint, each subset, each superset. So, for that I have given a clear definition which I will try to show you. Each disjoint, each subset, each superset. When I go for disjoint, it will tell that it should not have common elements, that is it, because each disjoint, each subset, each superset will provide you always the result in Boolean, right. Let me prove it. Let me just take an example, because if I just take the same example here, A dot is disjoint. You just need not worry, A dot, you press A dot, you give, you wait for it, is disjoint. If I go for is disjoint of B, now you get false because you don't have, you already have common elements. The common elements are, you have 3 here. So, it should not have common elements. It should not have common elements. That means A is equal to 1, 4, 5, B is equal to 3, 6, 9. Because each disjoint will return true, it returns true if there are no common elements. That is very important point. Because where do we use this in the sense, if we try to create data in the format of set, if you do not want to have duplicates, then even mathematical operations are also possible. For that reason, we are discussing all of them. Okay? Now, when I just give this A dot is disjoint, A dot is disjoint of B, you get true now because you do not have any common elements. So, is disjoint, is subset, is superset will always gives you only Boolean result. Just keep that thing in mind always, because the above examples we have discussed, you can take only strings also and observe. Now, what do I do is, why can't I update A with 3, 6, 9, because I want to show you subset and superset, right. If you remember from your childhood, what does subset mean? Because here B is subset of A. What are the elements present in B are present in A, whereas A is superset of B, right, because A is holding majority of elements. Now, if I give B dot is subset, you see B dot is subset of A will give you true. Always is disjoint, is subset, is superset is giving you the result as Boolean. That means A is superset of B, subset, superset always returns you Boolean along with disjoint set. So, you need not worry about it, right. It is simple. And again these things are anyways possible, minimum of A, maximum of A and length. Length always gives you the number of items, and anyways type. So, type of A will give you the class as set. So, minimum maximum length always gives you the number. whatever it is, right, because set will never allow duplicate. So, this is very important when you try to work on set. And even if you remember, yesterday we have seen how to unpack the elements from a set, right, by using star operator. The same thing can be applicable. When I give star A, what is happening? Can't use start expression because you cannot print the variable like this. You need to use print of star A. You can see every element is unpacked from the set, because in the tuple also what happens, 1 4 5 6, if you give print of star A, you get every element unpacked. So, star is used for unpacking elements. So, just make it simple, right. So, minimum, maximum, length, type, always those built-in functions are applicable. That does not mean that you can repeat a set, it is not possible. A star 2 is not possible, you cannot repeat a set, but you can repeat a tuple and a list, and even you can repeat a string also, right, 23 times, yes. So, always make it simple. That is how we have seen how to create a set and what made set different from lists, tuples, and what are the possible methods over set along with mathematical set operations. So, union, intersection, disjoint, superset, subset, difference, symmetric difference. Always remember, bar is for union, ampersand is for intersection, minus is for difference, cap is for symmetric difference. Then if you practice it, it will be very much easier to understand. Now, we will understand how to use curly braces again with the help of pairs when we go for the concept of dictionaries. Okay? So, make it simple when you work on this.